Right, so before you guys start with the podcast, मैं तुम्हें बस इतना बताना चाहता हूँ that this is extremely insightful. यहाँ पे तुम्हें बहुत सारी इन्फॉर्मेशन देखने को मिलेगी, so make sure you have a notebook with you and सारे चीज़ों को भाई नोट लेते रहना. And Chien how and I have decided कि अगर 10,000 likes इस वीडियो पे होते, which is almost an impossible target, but if you guys hit that target and if you guys show the love in the comments, then what we will do is we'll bring a completely free batch maybe for Olympiads, yeah, something that you guys will absolutely love, and that'll be completely free. So if you want that, then 10,000 likes भाई definitely reasonable है. And comments में भाई बताना कि तुम्हें ये video podcast पसंद आई कि नहीं. I'll be getting a lot more people as well. So yeah, now you guys can move ahead with the podcast. Make sure सारी चीज़ को एक सिटिंग में देख लो, क्योंकि अगर तुम्हें इंडिया को कभी रिप्रेजेंट करने का मन किया हुआ है कि तुम्हें फिजिक्स ओलंपियाड में रिप्रेजेंट करनी है, मैथ ओलंपियाड में रिप्रेजेंट करनी है इंडिया को आज से 1 साल 2 साल या 3 साल बाद, then this video will be very crucial for you. So now you guys can start with the podcast. Chalo, bye bye. All right, so welcome everyone, and today I'm with someone really special. So this dude has cracked everything. So he has cracked the International Physics Olympiad, and he has also secured a silver medal. And you know what? I'll give it to you. Why don't you just introduce yourself?
Sure. Thanks so much for having me. It's the first time I'm being invited to such a big podcast with a big channel like yours.
That's
Yeah, I'm Chien Hao. I did a bit of high school physics Olympiad. I also did a bit of comparative programming, and I'm studying computer science at NUS right now. But I'm still trying to do a bit of physics at the side. I also enjoy a bit of theoretical physics, like things like high energy physics, string theory. That's all in my interest. Yeah. Thanks so much again.
No worries. Okay. So basically, what we want to do today is have a discussion on how students can really level themselves up and come up to an Olympiad level. So let's first start with the question that how did you actually realize that you had a passion for physics, and when was it?
Yeah. Sure. So I think my interest started in so my story starts in around secondary 1. So that's when I was 13 years old. I'm not sure what grade that is in India, but I was 13 and I remember I really wanted to build a Tesla coil. So I realized that a lot of my electronics knowledge was lacking. So I started watching Walter Lewin's 802, the MIT 802 electromagnetism series, and that's kind of when I realized that I didn't know like things like multivariate calculus back then, but that's when I realized that a lot of the concepts he described was actually very intuitive, and I still watch it to this day, right? There's times I just go back and review the concepts, and that's when I really fell in love with physics. Yeah, so that's how my interest started.
So other than that Tesla coil, what did you explore in the initial days? So yeah,
right. What did I explore?
Yeah.
I think in the early days, after watching the lecture series, I realized that I enjoy physics quite a lot, and at the same time, my dad also got me a book on Newtonian mechanics.
Okay.
So that's when I realized that's when I learned like calculus was really a big part in physics. So yeah, mainly those two. I think these are the main two things that kicked off my interest. Around secondary 3 or 15 years old, I started gaining an interest in quantum, and that's when I would say that's when my interest really took off even more. So that's how I started.
I see. And do you remember the name of the book?
So the book was the Newtonian mechanics book was called Newtonian Mechanics for Undergraduates.
Okay.
Yeah, and
Author?
the author, I don't remember the author.
Oh, that's okay.
Yeah, but I also really enjoyed Leonard Susskind's book on the theoretical minimum, right? Both the classical and the quantum one. And now he has a new one, right, on field theory and wait, sorry. There's I think there's 3 in total.
Okay.
I can't remember. Don't quote me on that. But he has a new one on general relativity also, and I think those are really good books to begin with. Yeah.
Okay, so now let's just come to the point, right? So basically, if a student, right, who knows nothing in physics, right, he just wants to start from scratch. So how should he, proceed? What books should he follow? What resources and lectures, basically everything, so that he can come up to your level in physics and maybe crack the International Physics Olympiad. So yeah, just
sure. I think there's a lot of factors at play,
Yeah.
but everyone learns differently also. But how I might imagine a person can walk a similar path is I always like to begin with intuition, because if you try to stare at textbooks, it can be quite daunting to learn everything at once. So the main method of how I get started on a topic is mainly through lectures. Even today, whether it's computer science or physics or math, I try to find lectures that are related. So I really enjoyed Walter Lewin's 801, 802, 803 series. I think those are he really explains the intuition very well. So finding good lectures and getting intuition first without really understanding too much of the math. And as you get a good intuition, that's when you can try to, usually those videos they'll give you good intuition, but they don't really go so in depth. So that's where you can pick up certain textbooks, and I can list a few textbooks also, but that's where you can look at textbooks to really deepen your knowledge. So I'll recommend going for videos first to build intuition, then look at textbooks and problems to get a more solid understanding. Yeah.
I see. So how long do you think it should take ideally for someone who's starting today to be at a level that they can crack the International Physics Olympiad?
Actually, I've known people. Okay, personally, I've been interested in physics. I've been passionate about physics for quite long, but I've definitely known friends who started quite late, right? So I think one nice thing about physics is that okay, I might be biased because this is the way I see things, like based on my personal experience. But usually Olympiads like coding Olympiad or math Olympiad, they require a lot more years of experience. But things like physics, chemistry, and biology, the science Olympiads, they are you can start later and still kind of catch up or not be in too big of a disadvantaged position. Because throughout the years we have had various Olympiad competitions. So like in secondary 4 or 16 years old in Singapore, Singapore sends people to represent European Physics Olympiad, and then in only when you're 18 in year 6, then you go for the international one. So I've seen people who have done well in U4 and not go international, and I've also seen the other way around. So people who have not gone for U4, right, or didn't really take part in the secondary 1 to 4, like 13 to 16 years old, but later on go on to represent Singapore in IPHO. So
I see. So basically your main advice is that first build the intuition, and for that they can use the Walter Lewin lectures, 801, 802, and was it 801, 802 and 823? Yeah, so basically them, and once they have built that intuition, then how do you think they should move forward from there? How should they develop their mathematical skills? So maybe like a few resources on them.
Right. I think having a strong math foundation in calculus is very important. Personally, okay, calculus calculus is I think is simple enough to pick up almost anywhere. So I personally use mathsisfun.com. That was a it's a very kiddish website that's where I learned most of my calculus. But I think for multivariate calculus, on the other hand, which is arguably a more complicated topic, if you understand electromagnetism, you really need to know multivariate calculus very well. So to understand multivariate calculus, vector calculus, I highly recommend the Khan Academy. Khan Academy is taught by the same guy who teaches 3 Blue 1 Brown. The same guy who has a YouTube channel, 3 Blue 1 Brown, Grant Sanderson.
Yes.
Yeah, he also teaches multivariate calculus in Khan Academy.
I see.
And his explanations are just phenomenal. It's just I really enjoyed that lecture series.
Okay.
Yeah.
So that's how they build a mathematical foundation. And let's say they have that intuition built, the mathematical foundation. So basically the mathematical foundation ends at multivariable calculus.
I think so.
For Olympiads.
Yeah.
So basically, could you give maybe a list of topics that they should focus on more on, basically to build that math foundation?
Perhaps in not just multivariate calculus, like the entire range of math topics?
Yeah, entire range of.
I see. I think, okay, so I mean we need to know basic algebra and like how the manipulations and all that. And then from there, when you learn things like calculus, I think in physics Olympiad we use a lot of Taylor series. So knowing how to differentiate, integrate, those are quite basic. So okay, to go into a bit more detail, I think that's where I can use this
Yeah.
iPad a bit. So for calculus, there's there's clearly differentiation and integration.
Mm-hmm.
Those are basic concepts, and I think for integrals there's three. There's a few techniques like U substitution, integral by parts, and so on. So for integration, there are a few techniques like U substitution, integral by parts. But I think a lot of it that appears in a lot of integration that appears in electromagnetism is knowing the 1/r integrals. So like knowing the 1/r dx integrals, 1/r squared dx, and 1/r cubed. So this when I say r, in this case I mean r equals to x squared plus a squared square root, right? So r is a distance from if this is a triangle like this, then r is this distance.
Yeah.
And in this case the first integral here appears in calculation of potentials like phi of r, and the last integral here appears in calculation of electric fields,
Mm-hmm.
E of r. So I think knowing these three integrals is quite because often the working in like textbooks, they like to show the physics and the math together, but
Yeah.
sometimes isolating the integrals and knowing them by themselves, they can give you more confidence, because you realize that when you reach a certain step, it's just math from there.
Yeah.
And so it allows you to isolate the math from the physics, and that makes the entire working less daunting also. So instead of worrying about like all the constants in the integral, on top of the integral, you can just realize that the math part of it is actually really simple. It's just these three integrals.
Mm-hmm.
So yeah, so besides differentiation and integration, there's also, I think, Taylor something you should know very well. Knowing how to Taylor expand, knowing things like binomial expansion of like 1 plus x to the n is approximately 1 plus nx. Then the higher order terms are O of x squared. These things appear in like oscillations.
Mm-hmm.
When you want to expand around some potential. So like things like omega equals to u prime prime of the equilibrium point divided by the mass, right?
Yeah.
This is where a lot of like the Taylor expansion comes in also. And and this is mainly for basic calculus. Then for vector calculus, we have our line integrals,
Yes.
surface integrals, volume integrals.
Mm-hmm.
So I think surface integrals, and after knowing all this, there's also all the theorems, all the Stokes theorems that relate them, like Green's theorem and Stokes theorem also. Yeah. So knowing these is vector calculus is mainly more applied for electromagnetism.
I see.
Yeah. So that's roughly a list of topics. Actually, there's a bit more.
Mm-hmm.
Can I elaborate?
Yeah, sure.
So on top of that, I think roughly speaking,
Mm-hmm.
calculus and vector calculus covers like mechanics and electromagnetism. But when we move to topics like let's say for oscillations, right? There's knowing a bit of linear algebra might help also. So I think a classic problem will be if there is a bunch of spring mass systems like that,
Mm-hmm.
and we want to find the different modes of oscillation. So usually we will write some. Usually when you write down the equations of motion, it will lead to some coupled ODEs, coupled differential equations, and this is where I see that because when we face this problem in like let's say the national training,
Mm-hmm.
one way that students understand this is just by we usually start off with ansatz and we substitute it back in and we find the various modes, right?
Yep.
But I think a lot of students, when they see this, they don't fully understand what's going on, and knowing linear algebra will help you understand that these couple ODEs, they are actually a linear, they actually form a linear differential equation, and that means that linear combination of solutions can form solutions as well.
Mm-hmm.
And from there, linear algebra also is related to like Fourier analysis, where you can have some arbitrary motion of these two oscillators can be broken down into the various oscillation modes. So knowing linear algebra and knowing Fourier theory and all that is actually very richly related. Because we can think of like the idea that functions are vectors. Functions are actually vectors in a very literal sense, right? These are ideas that when it comes to oscillations and especially quantum mechanics, if okay, this is going a bit out of range of physics Olympiad and JEE, but if you really want to understand quantum mechanics, right, Schrödinger equation, all that, knowing linear algebra is very, very important also. So that's actually where I'll say that's where my interest really picked up, when I saw like bracket notation, like quantum states and stuff like that, and Schrödinger equation. That's when I realized that wow, like there's actually a lot of rich math in physics, and that's really what accelerated my love for physics.
I see.
Yeah. So I hope that this is comprehensive enough.
Yeah, definitely. So right. So basically, to conclude all the points, basically, what you should do is first develop your intuitions, and for that you can use the lectures of Walter Lewin and many other professors. Once you're done with that, you can start on developing your mathematical skills. And for mathematical skills, you should focus on single variable calculus, then move on to multivariable and also linear algebra. But linear algebra, I feel, is a little more focused on quantum mechanics, right? So initially you should focus on calculus and the multivariable calculus. And once you're done with that, then maybe you can move on to the more standard books. I think vector calculus as well, because that's very important for electrodynamics. So once you're done with the foundation of mathematics, you can move on to the more fundamental books. So what books would you recommend for each one? Let's start with classical mechanics first.
Right. Yeah. I'm excited to get to this part. So
yeah.
I'm going to list down my favorite books for all of for studying.
Definitely. Yeah.
All our topics.
Yeah.
So for classical mechanics, I really like Morin.
David Morin.
Morin mechanics. And I think Morin is a slightly more Morin gives you a bit more depth, like especially with topics like I think chapter 9 or something is on rotation, where they go to like inertia tensor and very, very fancy stuff.
Yeah, I see.
So Morin really gives you a lot more depth. But if you're looking for a more introductory book, I really enjoyed Newtonian mechanics for undergrads.
Was it that MIT one?
Sorry, I really don't remember.
Okay.
But you can probably put a link to the book in the description.
Sure.
Yeah.
Because I have a Newtonian mechanics book.
I see.
And I think that is taught to undergrads at MIT.
I see.
Right.
I see.
So I'm not sure if it's the same book.
Sure.
But yeah, sure. Okay.
Yeah. So I really enjoyed. This was more of an introductory book. Whereas the Morin really, I think the Morin really gives you as much depth as you need for IFO.
Okay.
So that's almost the maximum I'll go for classical mechanics. And even now, there's still a lot of chapters in Morin that I don't understand, and I'm still studying along the way. Yeah. So that's for classical mechanics.
What about Klepner and Kolenkov?
I've never actually used those books before. I've heard people might like. Okay, so these are books that I've heard, but I don't personally use. I've heard that people in NUS High, they like Landau. NUS High is a high school in Singapore.
Yeah,
and they like Landau a lot. Like I think Landau has it's a series of 10 books or something. So they like Landau also. I've heard people like Griffiths, but I don't really like Griffiths myself. Yeah. So besides that, there's also, I also personally use competitive physics.
Oh yeah.
Yeah, that's a classic for physics Olympiad.
Yes.
But do note that the problems might be a bit hard.
Well, definitely, you should not do this before building on your fundamentals.
Yeah, even after, even as I was participating in IPHO, I think there was still a lot of questions in competitive physics that I cannot do, and I think it's even safe to say that today I can't do all the questions in it. Some of it is not. It's like some of it is just you need a bit of inspiration as well. So that's definitely I think competitive physics is something that you shouldn't be too you shouldn't be too sad if you can't solve the problems in it.
Yeah.
Because when I tried to do it I tried to start with competitive physics also, and it was just very demoralizing.
Yeah, I tried it too, and I wasn't able to get
like there's 1-star problems, and those are like somewhat difficult already.
Yeah.
And then you go 2-star, and then there's only like maybe 3 or 4 like 2-star problems, and then after it's all 3-star, and you're just like,
yeah, the 3-star ones are almost like impossible.
Yeah.
Yeah.
So these are the books I like for. I think when people ask me, I always recommend Morin. I really like his exposition a lot.
I see.
Yeah.
So that's classical mechanics. Now let's move on to electrodynamics.
Sure.
Yeah.
So one more thing is for classical mechanics, I like to watch the 801 lecture series by Walter Lewin.
Okay.
This is really very introductory. So I'll say it's even more introductory than the Newtonian mechanics for undergrad book. So this is really like, if you're really starting from nothing, right?
Yeah.
Then 801 is a good place to start. Yeah.
Definitely. I think 801s can be skipped if you have built the foundations, right? So if you know kinematics and if you know rigid body dynamics to a basic level, I think you can skip that and move on directly to the further. What other lectures would you recommend? Because in India, most people actually prefer watching lectures rather than reading books.
I see.
So are there any other lecture series or courses that students can use?
Okay, personally, I also tried to watch a bit of Leonard Susskind, but his classes weren't that structured. I think his classes were more of casual kind of discussion. So I don't think I think for a lot of topics, by just searching the topic name, a lot of good videos will come up also. Let the YouTube algorithm do its work. I think Khan Academy is definitely good. I'm sure there's a lot of right. There's actually there's this guy called like Michael Van Biezen or something.
Oh yeah, Michel Van Biezen.
Yeah, Michel. I lecture online.
Yeah, I lecture. It's really good.
So I lecture online is something I also watch a lot of, and mainly he goes through a lot of problems.
Yeah.
He goes through a lot of examples.
Yeah.
And that can help you if you don't want to just watch like concepts and like lectures. You want to see someone solving a problem. Then I lecture online has a heck load of them. Yeah, I think that roughly that's all that comes to mind for classical.
Okay.
Then for electromagnetism, how I started was the first step I took was to watch 802, and 802 is so good that even without I was 13 years old, I didn't even know such a thing as I didn't even know what was vector calculus. But when he explained like what the surface integral was doing, it made so much sense that I kind of learned vector calculus through 802 also.
Okay.
Right? Not very formally. So but it gave me the intuition, like ideas like flux or like ideas like the line integral, like marching along the line and summing them up. So and taking the dot product, right? All that. 802 was really very good for introductory, for beginners. And after that, once again, I really enjoy Morin. I think the book is called like Morin and Purcell or something.
Yeah, Morin and Purcell.
Yeah. So
what about Griffith?
Once again, I heard of people liking Griffiths, but I never really used it myself.
Okay.
Yeah. I just like Morin a lot more for some reason.
So you'd recommend people to just refer to a single book if they want to compete in the physics Olympiad, or should they refer to multiple books?
I think you should definitely explore multiple books, right, and see what you like and what sticks with you. So understanding one concept, you try to read different authors, even though the different authors might be saying the exact same thing, but occasionally they'll have different perspectives or different explanations, and that's really what helps you build a solid understanding. Yeah. So after that, Morin is a very great textbook once again, and once again it's very very in depth also. Like they'll teach all the exactly what happens. Like I think one example that comes to mind is Faraday's law. Faraday's law is a bit nuanced. You can see it from like 3 different pictures. You can see it as the magnet that is moving away, or a decreasing magnetic field, and so you can see it from different perspectives, and Morin really explains all these thought experiments very well. So that's why I really enjoyed. So these are mainly the 2 resources I can think of once again, I lecture online is also has a lot of problems there. Mainly these two. Yeah.
Okay. So again, before you jump on to, I think, Morin, you should do vector calculus very well. Otherwise, you won't be able to understand what's exactly happening there. And so that's with electrodynamics. Now, after classical mechanics and electrodynamics, what do you move on to?
I think one topic is definitely thermodynamics.
Okay.
So this was something that I struggled with for quite a while also. I struggled to find good resources.
Okay.
And all the things like potentials, like Helmholtz free energy and all that. That was really confusing. And so for this, I recommend Blundell. For introductory lectures, I haven't really found a set of lectures that I really enjoy. I haven't really found good lectures yet. Maybe if I have some time, I should make a lecture series on that. But for the textbook, I really enjoyed Blundell. It was also recommended by seniors of mine and the national training team. And Blundell, he explained things from statistical mechanics. So I think to really understand thermodynamics, you need to dive into StatMech also.
Yeah.
Because things like and at first it might seem very irrelevant because like why are you doing like counting the microstates, like sometimes it feels like you're very far detached from thermodynamics, but at the end of the day, knowing StatMech would bring you very far also in if you want to pursue physics in university or theoretical physics. StatMech is a very foundational topic, and it's actually a very, very big branch of physics, and it's Leonard Susskind said that it's like basically half of physics as well. So knowing StatMech is important. And there's actually a lot of physics under StatMech, like things like the partition function and all that. So I think knowing just enough StatMech, then reading Blundell would give you a basic foundation of StatMech that's just enough for thermodynamics without going too much, like without wasting too much time. And these are the main two resources that I.
Basically, how long would you suggest a student to spend on each part, like on classical mechanics? How long should they spend?
Okay, I will say that it really depends on try to do things that try to do a topic that you like. Try to follow your interests. Like if the exam is far away and you still have time, then you can kind of afford to choose what you like, and choosing what you like will help you. It just motivates you to study more, right?
Yeah.
When you enjoy the thing you're studying, it doesn't feel like you're studying.
Yeah, exactly.
Right? I think that's the key to success also, right? Because it's very hard to compete against someone who studies all day long because they just enjoy it, right?
Exactly. Yeah.
So finding the passion, and I think that's also what watching these lectures are useful for. So watching 802, really seeing his energy and his love for physics, it really motivates you. It is really very contagious. And once you fall in love with physics, that's how you learn a lot more physics, because you just naturally read up a lot more broadly. And so I think in terms of time allocation, I guess if you really want numbers, I can just say like if you throw in oscillations also, then and oscillations and other miscellaneous topic, then perhaps like 20% each, right, for all these 5 topics. But I try to go by the philosophy of studying what I feel like studying.
Okay.
Right. Yeah. So when I wake up one day, whenever I feel like studying, I'll just go and study it.
I see.
Yeah.
What about optics?
Oh, right, optics. I guess under miscellaneous, there's optics. So there's geometric optics and wave optics, right? I think geometric optics is a small enough topic that it isn't too much of a concern. You mainly need to know a few formulas, like the lens formula, maybe the lens maker formula as well. And you also need to learn. You also need to know how to draw straight lines well.
Yeah.
I think geometric optics isn't too deep of a topic. But for wave optics, I think having a good understanding of oscillations and naturally, because oscillations and waves are quite related. Like oscillations are solutions to the SHM equation, right? And then wave equations are solutions to the wave equation, and they both involve Fourier quite a lot, right? Like they're both quite related to Fourier analysis. So if you understand oscillations and you understand uh, Fourier Fourier theory quite well, then it quite naturally leads to you can extend the understanding to waves quite well also. And once you understand waves as a whole, like waves in general, then optics are just electromagnetic waves. So all the phase shift and all that is quite it's quite intuitive from if you understand waves. Yeah.
I see. So we have talked about how long it should take, and so basically in total, how long do you think it should take ideally? Right. Let's say classical mechanics, electrodynamics, optics, everything put together. How long should it take for a student who actually wants to crack the Olympiad? How long should it take?
Okay, so I think hypothetically, assuming that you have no like other commitments like school and all that, if I were to sit down with starting from zero and going all the way to the level at which I was when I participated in IPHO, I think it might take me roughly 3 years of intense studying.
Okay.
Yeah, of course, spreading it out across more years means that there's more time to slowly pick up concepts. But I think if I went like really zero to IPHO, 3 years of intense studying, like maybe 8 hours a day, 7 days a week.
Okay.
I think that's roughly how much I'll gauge. Yeah.
I see. So, guys, it's not easy. Alright, if you were thinking you could do this in 6 months, that's not going to happen unless you really have a very strong base, right? And without that base, it's going to take you I think the majority of the time goes in developing that base and intuition and that mathematical foundation. But if you already have that, I think after that it's just reading some theory, knowing how to apply it, and maybe enjoying physics, right?
Right.
So yeah, without enjoying physics, you won't be able to crack IPHO
Yeah.
definitely. So again, this was an ideal case where a student does not go to school or whatever, right? So how did you manage your time back then, right? How do you manage your time right now to, give time to your interest in physics as well as computer science? And how should a student who is currently in school, also preparing for maybe other exams like JEE Advanced, how can they focus on Olympiads, and how much time should they devote every day?
Right. So in terms of time management, okay, I may not be the best example because I kind of neglected a bit of school. You shouldn't follow my example.
Yeah.
Grades are important. School grades are important. But I think personally, because I think it's also a bit unique to my story, because in from around secondary 1 to 3, I was quite focused on computing, and because and thankfully I won a gold medal at the local computing Olympiad, so that kind of gave me a bit of security, because the local university NUS, they kind of give preference to computing Olympiad medalists, so that gave me a bit of security, and I felt like even if my grades in school weren't so good, at least I have a safety net to fall back on. So I really didn't enjoy certain school subjects, and I spent almost all of my time studying things I like, which is physics and maybe a bit of computing. So maybe in terms of how much time someone needs, if they spend 8 hours a day and just don't have any school, maybe there's a bit of accurate reflection of my timetable, because when I went to school, sometimes during lessons that I didn't enjoy, I would also just do my own things and study my own things. I think especially in the later 2 years, like 17 and 18, that's when I really felt like when I go to school, it's just doing my own things, and I really didn't quite enjoy that lesson, the content in school. So of course I don't think that's a good example, because I think a lot of people who focus on things like Olympiads, they underestimate the importance of school grades. And even as a personal anecdote, even though I have IPHO and like the local computing Olympiad NOI, I still, when it comes to like scholarships and like getting places in schools, I actually still lose to my peers who just got perfect grades and like no extracurriculars. So I'm not trying to discourage you guys from not trying to discourage people from doing Olympiad. I think definitely is a good thing to pursue, but maybe just try to take note of your school grades also and don't let them drop. Yeah, I don't think I'm the best example. I'm not sure if
But
that's
do you not think that MIT and maybe Harvard and these institutes actually give preference to students who have cracked Olympiads?
mm,
Because majority
mm,
of the people that I see getting into either physics at
right,
MIT are mostly these gold medalists and
right.
silver medalists. Yeah.
I think these people, I've friends who are able to juggle, um, who are able to juggle school as well as Olympiad, and those eventually go on to places like MIT and
Mm-hmm.
other top unis. I, I'm not really one of them. I think personally I really just zeroed in on the physics Olympiad because I really enjoyed it, and I was just like, if I like physics so much, why should I spend time on other subjects that I didn't enjoy, like the languages or like the humanities. But yeah, I think I feel like if you're to if 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 you're to be in my shoes, it's a bit of a gamble because focusing all your energy on physics Olympiad and like computing Olympiad means that either you go big or you go home, right? Either
Yeah.
you get you get international medals, and then you can go to good universities, or you don't get anything, and because it's all very variable, right? At the day of the competition, if you're too stressed or something, or you make a careless mistake, that could change the trajectory of life a lot, and that's quite a big of a gamble. So if you put all your energy on like Olympiads, and you don't do well in Olympiads, and on top of that you neglected schoolwork, then in the end you have like nothing.
Yeah.
Right? So I think trying to find a balance is important, and everyone has their own balance. Personally, I went with the I'll just do what I like and not care that approach, but I don't recommend people do the same. Yeah, I think finding a balance with schoolwork, Olympiads, and exercise, right, is and social, like friendships and all that, is very important also. So I think you should just try to follow your passion. If your passion really is in physics and you really enjoy it, and you can feel like you can study 8 hours a day with no and you don't feel like you're studying at all, then by all means, maybe you can put more time into it. But if you feel like studying Olympia is a chore, or like is taking a toll on your mental health, then you should probably just spend a decent amount of time on like schoolwork also, and not and not neglect it. Yeah.
Mm-hmm. So throughout this journey, did you have a mentor or a person who guided you?
Right. So a mentor, I definitely had seniors who helped me, and I think having a mentor is very, very important.
Mm-hmm.
For computing, I had seniors who helped me debug my code and all that, and without them, I really don't think I could have learned that much. And for physics, I had a physics mentor I had a physics research mentor. But maybe not so much for Olympiad. But I definitely did have like seniors and tutors who I engaged in, and when they explained certain concepts to me, I think where the role of a tutor is to fill in the gaps that you don't understand. So when you study something from a textbook, you often have like questions, like the textbook might have mistakes or certain holes that you just don't understand, and that's where a tutor can really fill it. So but I think what a tutor shouldn't be is someone who introduces you the topic from nothing. So like what I'm saying is that if you're getting a tutor, if you're paying someone to teach you, you need to go prepared. So you need to read the textbook, have questions, and then approach the tutor who can fill up those gaps for you. If you're approaching a tutor who just sits down with you and reads through the textbook with you, I don't think that's as effective. And yeah, it's just not that good use of time and money. Yeah. So try to find a good tutor who can fill in the gaps for you. And when you approach him or her, you must have read the textbook and have questions of your own. I think that's
see.
really how you learn more effectively.
So have you ever seen a JEE Advanced paper?
I have seen some questions before. I
Okay.
don't think I've seen the entire paper before. Yeah.
So do you have any idea of like the level of questions or anything?
I think they're on par with some of the I think some of the harder questions are actually on par with like International Physics Olympiad kind of level.
Okay.
I'm not sure about the range of difficulty.
Yes.
Yeah.
So there are very few questions actually. It's not that majority of it is at par. So very few questions. Almost every year, maybe you could see one or two such questions that are made such that students don't score full marks. So that is just to keep the pride of the JEE Advanced exam. So till date, no one has ever scored full in it.
Oh wow.
Yeah. So that's how they make it.
I see.
But yeah. So basically, let's say a student is preparing for JEE Advanced, because most of my viewers are already pretty much preparing for JEE Advanced, and they might have a solid foundation on physics. Now let's just say they have done those level of problems. Right now, how do they bridge? Right, how do they go from JEE Advanced? Should they directly get into the textbooks? Right, because we aren't taught multivariable calculus. Right, we aren't taught vector calculus. So what part should they skip, and how can they bridge a lot quicker? Right, instead of spending 3 years, they've already built the foundation. How do they go quicker onto the Olympiad level?
Right. So you're saying if somebody has kind of decent score in JEE Advanced and they have a decent understanding of physics already, how do they go further and let's say prepare for the International Olympiad? I think if the students are already at the level of JEE Advanced, they can immediately go to textbooks like Morin and they can immediately go to textbooks like Morin Classical Mechanics or Morin Electrodynamics. I think that gap should be traversable. In terms of mathematical foundation, personally, I never quite worry too much about it. Like, I always go by the approach of I try to study the physics first, and I see what math I need to learn to catch up with the physics. So if I'm studying Maxwell's equations and I see that, oh, I don't understand what this inverted triangle means, then that's where I go and learn the related math to try to catch up with it. And I feel like with the internet, there's so many good resources online that if you are determined enough, and I think the key to success really is patience to try again and again and again, and if you're determined enough, you can definitely learn any topic online. So I think one key advice is that don't be discouraged if you're trying to understand a concept many times and still don't understand it. I think I myself, there are many times where I felt like there's just some topic that I just can't really break through, and sometimes all you need is a friend or a teacher who can explain the intuition for it. And so learning is really non-linear in some sense. Like, you may be thinking like, I've visited this topic 10 times already and I'm still only 5% sure, but maybe the 11th time you visit it, somebody just gives you an intuition, or some website you read online, or some set of notes online just says a certain set of phrases in the correct order that really makes it click for you, and you immediately shoot up to like 95%.
Yeah, that's so true.
So I think I think one thing is that learning is definitely a very non-linear process, and don't be discouraged if you're not breaking ground, right, in the first few attempts.
So there's so many topics, right, to keep track of. Do you make notes? How do you revise? Like, how do you just make sure that while you're studying electrodynamics, you don't forget classical mechanics? Right.
I think one aspect is definitely to try to toggle between the topics quite often. Right. I do find that if I study a certain topic for too long, I do get rusty with the other topics. But I think trying to, especially near the exams, toggling between different topics is a trick that you can use to keep your memory fresh, and at the same time not be too stressed about needing to study a certain topic as the exam is near. So I think maybe the strategy that I personally take is when it's far away from the exams, like the key milestone periods like the selection test or like the Olympiad, I would try to study by one topic very deeply and try to build a very strong foundation and intuition for it. And as it gets nearer the test or something, or the certain milestone, I'll try to do the practice papers, and the practice papers are usually mixed, right? So that's where you can see the whole range of questions, the range of topics, and you can revise all the topics without and make sure that all of them are not rusty.
I see. So do you like make notes
Oh
or?
right. Sorry about making notes. I feel I I remember I like to bring around this A4 A4 notebook
Mm-hmm.
that allow you to tear the pages out. I
Mm-hmm.
think I think personally my note taking system was uh when I did questions I was I'll try to copy, I'll try to understand the key each key equation in the textbook, and my notes will be mainly the working to get there. So basically I'm working through a textbook, and my notes weren't really like I didn't really write a lot of words in my I didn't really write a lot of words in my notes. Mainly was derivations
Yeah.
for these. And when I so it was like a lot, my notes would look like a lot of working, just plain working, almost no words. And then with a final answer I'll just box it up,
Mm-hmm.
and that's kind of my notes. And the thing I like about those notebooks that allow you to tear the paper out is that a lot of the working you do is probably junk and you don't really want to keep it, but you can tear out certain pages that you really like, and you can keep them in a folder, and nearing the exam you can review the more important equations that you work through.
Mm-hmm.
So that's my note taking method wasn't very systematic. It was by no means neat at all. It was just a no highlighter, no fancy colors. Just I had one pen that I really enjoyed, the Sarasa pen.
Yeah.
And I just used that on all my notes.
Uh-huh.
And it's just black. It's just blue ink on white paper. That's all. Yeah.
Okay. So, going forward, what do you want to pursue? Like, do you want to, go and get into physics? Do you want to
Mhm.
get into computer science? And let's just say there's a student, right? This is a follow-up question to that. So, if there's a student who genuinely likes physics right now and they want to pursue it as their career, so how can they do that,
Mhm.
right? So, maybe giving them like a basic roadmap. Yeah.
Right. I think personally, I'm quite interested in this intersection of physics and computer science, right? So especially in areas like high performance computing, where you're using supercomputers to simulate material science,
Mm-hmm.
right? Things like density functional theory (DFT), basically computational physics, right? That lies at the intersection of both my interests. So I'll probably be doing something related to that. But as for pursuing maybe a career in physics, or or being a physicist, I think one advice I'll definitely give is that when you're young, try not to worry about career too much, right? When you're young, try to really learn the subject for 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 what it is, right? And don't worry about um making money out of the topic, right? And I think I also had a privilege of having a supportive like family who could like fund my experiments and things like that. So not needing to worry too much about like food and stuff, but I think when you're young, try to study a topic if you really enjoy it, and don't worry too much about the cost. Like don't worry too much about whether that topic, the subject that you like, can be a viable career. Um, there are a lot of career paths open later on that, like maybe you can be a physics teacher, like, or you can be or can be a physicist. There's a lot of career paths that I'm sure that any topic that you're interested in, there's a lot of career paths that can be branched from there. I think mainly when you're when you're starting to choose your university, that's when these considerations come more into play. And I think for myself, they also started to come into play as I was entering university. So at first I was thinking, when I was studying physics Olympiad and theoretical physics, I was really set on just being a theoretical physicist, and that's all I had on my mind, right? And I think that's a good mentality to have when you're studying physics, right? Because you just want to be locked in to studying physics, and you just want to be focused on the subject and being good at that subject. But later on, I realized that my career aspirations did evolve a bit. So instead of like just being purely focused on theoretical physics, right? I realized that um theoretical physics as a in academia as a career is not as it can be tough sometimes, right, to bring food to the table.
Yeah.
And it's competitive, right?
Yeah.
So that's when I realized that I do need to diversify a bit into computer science, and that's also why I'm studying computer science and physics in university instead of just pure physics. So I think as for the viewers, I think most of them are probably not so old yet, right? They're probably quite young. So when you're young, just try to study the subject that you really love and study it hard and deeply, right? And only when you're starting to consider university, when you're applying to places, that's when you can take into consideration things like career and like finances, more into play.
So if you had just one piece of advice that you could give to students who want to prepare for the International Physics Olympiad, what would it be?
I think it would be really do what you enjoy, right? If you don't enjoy physics, it's okay, right? It's completely okay to not it's completely okay to not win a medal or anything. Just do what you enjoy. If you like chemistry, go for chemistry. If you like math, go for math. If you like computing. If you like other stuff like art or music, by all means just pursue it. I think I've seen enough data points that I realized that most of the people who succeed in their respective fields, right, be it humanities or sciences, they really enjoy what they're doing. So don't burn out yourself and stress yourself by competing with people who really enjoy a subject if you yourself don't really enjoy it. Right? It's really tough. I think a lot of people, when my peers around me, they saw me study physics, they're like wow, this guy studies physics like night and day, right? And the people I've seen go to like IBO and stuff, they really read the textbook like it's their bedtime story. It's like it's just when you really enjoy a topic, you just can't put it down, and that's the kind of passion that will really bring you far. So I think if you don't like any particular topic, it's also completely okay, right? Olympiads Olympiads are just a means to an end. Sometimes there's many other ways to succeed in future, right? And don't be too hard up if you don't make it to the international team or something. Life is very long, and Olympiads are just a very small chapter of that also. So I think my one word of advice would be just do what you enjoy and don't burn out.
That's so true. If you're competing against people who love what they're doing, and if you don't love it, you'll probably lose, and you're basically wasting your time, right? So don't just do physics for the hype of it. Don't just do Olympiads for the hype of it. Do it because you love it. And definitely, if you practice properly, strategic planning, you will definitely get there. So just love what you're doing. So anyways, it was amazing having you here.
Thanks.
And
it's my pleasure.
So if you guys want to watch, again, please give them your name. They would like to search you up. Sure. Your YouTube channel as well. So.
Right. My name is Chien. I think the YouTube channel is in the description below. I have mainly 2 YouTube channels. I think I have 3 YouTube channels, but they're not professional by any means. One of them is my personal channel where I upload anything I want, right? It could be a trip to China or something, right? Anything I want, not structured at all. Ironically, that's the most subscribers. And my other 2 channels are one for more proper physics videos and more properly edited computing videos, but none of them are really big, and just feel free to browse around. Let me know if you have any questions or what kind of content you want me to make. Thanks so much for having me.
So this was amazing, and if you guys want us to collaborate again, so we'll have the part 2. So if you want that, then the like goal is going to be, let's say, 5,000. Alright, 5,000 likes, and if we have that, we'll collaborate again and maybe come up with something even more interesting. And so till then, it was lovely having you here.
Thank you so much.
Alright, so see you guys. Bye bye.